My name is Hank Preston, and thank you for joining me for this look at CICD for the network. Now you may be asking yourself, what exactly is CICD? Well, CICD is an acronym that represents continuous development. And continuous development is an element of the DevOps process for software development, where the goal is to take away all of the manual interaction steps necessary to take code that developers wrote and make it available for use, and replace that with automation. The process of continuous development looks like this. After software developers do their code, in the continuous integration phase, all of the developers' code are brought together and integrated and then tested to make sure they work as a package. Following that is continuous delivery, where the software is packaged appropriately so that it can actually be installed by end users. And that installation actually happens in the continuous deployment phase, where application software is updated, configured for use, and put in the hands of the users. What we're interested in is how we can use those same principles in a net DevOps configuration pipeline. We'll treat our network as code and store that in source control. We'll propose our changes to the network in branches inside of source control, and our build servers will monitor the source control systems and kick off new builds when proposed changes are made. Entire test networks will be spun up automatically, onto which we can deploy the network configuration changes, test to validate that everything is working as expected, and then finally position those for deployment into a full production network. Well, enough of the talk and the slides. Let's see it in action. For this demonstration, what we're going to look at is how we can control SNMP configuration across our network using Network as Code, CICD, and specifically Ansible as our configuration management solution. So before we look at those pieces, let's actually check out the current configuration in our production network. I'm telnetting into one of my production switches, and we'll look at the SNMP configuration. We can see in here I've got secure read and secure write set up as my SNMP community strings, as well as hosts set up to use those strings as well. Now our goal is to be able to update those and fully manage them across the entire network without manually doing the configuration via CLI. To do this, the technology that we're using is Ansible to drive these. So the first step is to go ahead and update the configuration that's in there. So we can see in here that we've got secure read and secure write set up. I'm going to go ahead and update those to demo secure read and demo secure write. This is a variable file that will drive the actual configuration pushed out by Ansible. Now the change that I'm making here is inside of a branch of my source control system called dev. We look at this, we can see git status, and I am currently in the dev branch. The dev branch represents my development location. The master branch would be where our production deployment goes through. We do all our initial testing inside of this branch. Now before I push this modified file up to source control to kick off the full build, let's test and see if it's working locally first. To do this testing, I have a virtual iOS XE device running right on my laptop that I can use as a development instance. So I'll run this playbook against my host dev, which indicates my local workstation's version of that iOS device. We can see it here, 127.0.0.1. And now it is running that playbook fully against this test device, or this development environment. The first step is to remove the existing SNMP configuration, and we can see it removing secure read and secure write from the development switch. All right, the test run against my development instance looks good, so now the time has come where I can actually commit these to source control to kick off the process. To do that, let's check once again our status to verify that the only file we've changed is our variable file that represents all of the basic configuration details. Git add group vars all.yaml, we'll add this, and then I can commit this Good commit messages are always excellent so that other folks know what these changes were intended for. Now this commit is local to my laptop. With git push, this will actually send this up to the source control system. We can see that I've pushed this to the dev branch, and so if I go and I look at the dev branch in source control, I will indeed see that we've got the updated community strings for demo is the last commit that came through, and I can go and investigate inside of source control that we do indeed have the new demo secure read and demo secure write. Now once this commit hit the source control system, in this case GOGS, which is an open source control system, it sends a notification off to Drone. Drone is my build server that actually does the CICD process, and we can see we have an active job running for updated the SNMP community strings for demo, and it's running inside of the dev branch. We can watch as this runs through. The first step in the process was to start a test network. It starts this test network using Cisco's Viral platform to spin up an entire network simulation onto which we can deploy the network configuration. Once that simulation has been started, it goes ahead and it uses the Ansible playbook to push out those configuration changes to the test network. We'll watch as this process completes. An important part of CICD is actually making sure that your network or your configuration changes were successful. We can see here a step for run network tests, which is actually using a separate Ansible playbook to verify that the SNMP configurations are working successfully. We can see that they're working successfully because the Ansible system was able to pull out system name and other information using the updated SNMP community string. With the test complete, the final steps are to destroy the test network, to remove the temporary network that was spun up for testing, and then also to merge these changes to master. Because everything was successful, we are ready to send these off to our production network. We also see a Spark notify message. If I look inside of Cisco Spark, I can see that I did indeed get a notification message just a moment ago for the updated SNMP community strings for demo. So in the chat ops fashion, I didn't have to manually and physically watch the build progress. I can monitor it using my chat systems that are there. Now we can see now we actually have a second build running. In this case, it's the same commit, updated SNMP community strings for demo, but now it's been pushed to master. In our CICD process, the continuous delivery phase took the changes that were proposed in dev and moved those into master because they were accurate and functional changes. In this build phase, rather than deploying a test network and configuring there, we are deploying config prod network and running that same playbook against our production network to implement our final changes. Once those complete, we once again do the test to make sure that things look good, and we can indeed see that SNMP is still functioning on our production switches. Let's verify that it's actually working. To do that, we'll telnet once again into one of our production switches and check the current SNMP configuration. And as we would have expected, we do indeed see our community strings have been updated for both read-only and read-write, as well as our trap destination configurations down here. And notice that the old community strings have indeed been removed, which is a critical part of doing full configuration management. Thanks so much for joining me for this look at how CICD will work for network configuration management in the future. Today's example was just a very simple one, seeing how the components fit together and how the phases of CICD will work for networking. For a real production deployment using CICD across your entire network, there'll be far more details necessary for effective test networks and simulation, as well as validation and test tooling to ensure that your network configuration was successful. More on that to come in future videos, learning labs, and blog posts. Talk to you soon.